They found the whale fossil in a coastal deposit dating back 9 million years. A baleen whale 9 meters long, its skeleton preserved in sediment that once formed the ocean floor. But this wasn't a natural death. The ribs were shattered, not cracked, shattered. The chest cavity had been punctured with such force that bone fragments were driven inward. And across the vertebrae, the flippers, the skull itself, massive bite marks scored the surface. These weren't grazing wounds from a scavenger picking at a carcass. This was deliberate, calculated. The attacker had targeted the skeleton itself. What kind of predator doesn't go for soft tissue? What hunter ignores the easy meal and instead crushes bone? The answer lies in the teeth marks. Each one measured over 7 inches across, serrated edges, built not to slice flesh, but to break through the hardest structures a whale possessed, Megalodon. This wasn't opportunistic feeding. This was dominance. A predator that weaponized its entire anatomy to kill prey no modern shark would dare attack. The fossil record confirms it. Megalodon didn't just hunt whales, it dismantled them. The numbers tell the story before anything else. 40,000 pounds per square inch. That's the bite force Megalodon generated, 10 times stronger than a great white shark, more powerful than a Tyrannosaurus rex, the strongest bite in the entire animal kingdom. To understand what that means, consider the mechanics. A great white shark bites at roughly 4,000 psi. Formidable. Enough to puncture seal blubber and tear through muscle. But a great white targets soft tissue, the underbelly, the throat, places where resistance is minimal. Megalodon aimed for the skeleton. The jaws themselves measured 9 feet by 11 feet, a feeding apparatus large enough to swallow an orca in 5 bites. But size alone doesn't explain the devastation. The structure does. Megalodon teeth weren't designed like modern shark teeth. A great white's teeth are thin, blade-like, built for cutting. They slice. Megalodon teeth were thick, robust, 7 inches of serrated bone-crushing architecture. Each tooth sacrificed cutting efficiency for durability. This was an evolutionary trade-off. Thin teeth cut faster but break easier. Megalodon's teeth were built to withstand impact, to drive through rib cages, to shatter vertebrae without shattering themselves. The fossil evidence makes this undeniable. Whale ribs with Megalodon teeth embedded directly in the bone, not resting on the surface, embedded, driven in with such force that the tooth became lodged in the skeleton. That's not a bite, that's a collision. Compare this to modern predators. Great white sharks bite and retreat. They test the prey, inflict damage, then wait for blood loss to weaken the target. It's a war of attrition. Megalodon didn't retreat, it stayed engaged. The attack pattern on that 9-meter baleen whale fossil revealed something even more disturbing. The bite marks weren't concentrated on the belly or the tail, they covered the chest cavity. Megalodon broke through the rib cage to puncture the heart and lungs directly. No modern shark does this. The rib cage is the most defended part of a whale's anatomy, thick bone, layers of muscle. Attacking it requires not just power but commitment. Megalodon committed. The jaw structure supports this. Fossilized jaw fragments show that Megalodon's bite wasn't just strong, it was precise. The teeth interlocked when the jaws closed, creating a cage of serrated blades. Anything caught between them wasn't escaping, it was being processed. Scientists used 3-dimensional modeling to reconstruct how these jaws functioned. The force distribution wasn't uniform. The back teeth generated more pressure than the front. This meant Megalodon could grip with the front teeth and crush with the back, using its entire jaw as a mechanical vice. The implications are staggering. Modern sharks are opportunistic. They take what the ocean provides. Megalodon restructured the food chain around its capabilities. It didn't adapt to available prey. Prey adapted to avoid it. Whale fossils from the Miocene and Pliocene epochs show healed bite marks. Scars. Evidence that some whales survived Megalodon attacks. But survival didn't mean escape. It meant living in an ocean where the apex predator could strike from any angle at any time with enough force to break bones. This anatomy wasn't just for killing, it was for dominance. For establishing a presence so overwhelming that the mere threat of attack shaped behavior across entire species. Megalodon didn't hunt like a shark, it hunted like a siege weapon, and the fossil record is littered with the wreckage. But raw power means nothing without strategy. The fossil record reveals something even more disturbing than the bite force itself. Megalodon didn't kill quickly, it disabled first. Analysis of Pliocene whale remains shows a consistent pattern. Bite marks concentrate on specific anatomical targets, flippers and tail vertebrae, not the torso, not the head initially, the appendages. This is deliberate immobilization. Modern sharks go for immediate kills. A great white attacks from below, strikes the vital organs, then retreats while the prey bleeds out. Quick, efficient, minimal risk. Megalodon prolonged the hunt. Fossilized flipper bones from multiple whale species bear identical damage patterns. Deep lacerations where megalodon teeth severed muscle attachments. Shattered bone where the bite crushed the joint itself. A whale without functional flippers can't dive, can't maneuver, can't escape. The tail vertebrae show similar trauma. Megalodon targeted the base of the tail, the primary propulsion system for any cetacean. Bite marks on these vertebrae indicate crushing force applied directly to the spinal column. Sever that connection, and the whale becomes a drifting target. Why this strategy? Why not go straight for the kill? Because Megalodon hunted prey that could fight back. A full-grown baleen whale in the Miocene epoch measured up to 15 meters, larger than Megalodon itself. These weren't defenseless animals. A tail strike from a whale could inflict serious damage, flippers could batter an attacker. The only safe way to kill something that size was to remove its ability to retaliate. Evidence from a sperm whale fossil discovered in North Carolina adds another dimension. The specimen, a physeteroid sperm whale roughly 4 meters long, bears bite marks on the jaw itself, not the body, the jaw. Megalodon shattered the whale's ability to bite back. This represents the first known instance of antagonistic interaction between a sperm whale and an ottodontid shark recorded in the fossil record. The bite marks on the tooth roots indicate extraordinary force, enough to break the whale's jaw, enough to guarantee the whale couldn't defend itself. The chest cavity attacks follow the same logic. Unlike great whites, which avoid heavily defended areas, Megalodon broke through the rib cage to puncture the heart and lungs directly. Fossil evidence shows ribs driven inward, bone fragments scattered through the chest cavity, and teeth marks on the internal vertebrae. This wasn't scavenging. Scavengers avoid the hardest parts. They go for soft tissue for easy access. Megalodon targeted the most protected organs deliberately. The implications extend beyond individual kills. Fossilized whale ribs show healed bite marks, evidence that some whales survived Megalodon attacks. One particular specimen, a rib from an ancestral blue or humpback whale, bears 3 tooth marks, apparently from a juvenile Megalodon measuring 4 to 7 meters long. The rib healed. This means even juvenile Megalodon, sharks barely half the size of adults, attacked whales far larger than themselves. And some whales lived through it. They carried the scars. They remembered. This is ecosystem level intimidation. Megalodon didn't just kill for food. It established dominance through calculated violence. Every whale that survived carried evidence of Megalodon's power. Every pod that witnessed an attack learned to fear specific hunting grounds. The fossil record captures this in freeze frame. Bite marks on flippers, shattered tail vertebrae, punctured rib cages. Each fossil tells the same story. Megalodon attacked from any angle, stayed engaged through the entire kill, and inflicted catastrophic damage before delivering the final blow. Modern sharks are opportunistic. Megalodon was methodical. It didn't wait for weakness. It created weakness. Then it exploited it. The brutality wasn't random. It was adaptive. And the fossil evidence proves it worked. The brutality wasn't uniform. Megalodon adapted its strategy depending on the prey. Juvenile Megalodon inhabited warm coastal waters. Fossil evidence from these regions shows a completely different diet than adults. Young Megalodon hunted fish, sea turtles, dugongs, and small cetaceans. The prey was smaller. The attacks were less devastating. But the predatory instinct was already present. As Megalodon matured, everything changed. Adults moved offshore. They abandoned the coastal hunting grounds and specialized in large cetaceans. This represents a complete dietary transformation, an ontogenetic shift that fundamentally altered how Megalodon interacted with the ecosystem. The fossil record documents this transition through prey diversity. Dolphins, squalodontids, shark-toothed dolphins with their own formidable jaws, sperm whales, bowhead whales, rorquals, seals, sirenians. The list spans nearly every major marine mammal group in the Miocene and Pliocene oceans. Calcium isotope analysis confirms what the fossils suggest. Megalodon fed at a higher trophic level than any contemporary predator. Higher than great white sharks, higher than other apex predators sharing the same waters. Megalodon consumed animals already at the top of the food chain, but here's where it gets interesting. Dental microwear evidence from Mediterranean Megalodon specimens reveals something unexpected. Despite specializing in large prey, Megalodon maintained a generalist diet. Microscopic analysis of toothwear patterns shows evidence of invertebrates, marine reptiles, bony fish, and other sharks. Megalodon wasn't a specialist or a generalist, it was both. This adaptive flexibility explains its dominance. When large whales were abundant, Megalodon focused on them. When whale populations migrated or declined, Megalodon shifted to alternative prey without losing efficiency. Sea turtle fossils bear witness to this versatility. Bite marks on fossilized turtle remains show Megalodon didn't discriminate by size or difficulty. A turtle's shell, one of nature's most effective defenses, meant nothing to a predator with 40,000 psi of bite force. The sperm whale attacks reveal even more sophisticated adaptation. Fossil evidence suggests Megalodon targeted sperm whale head specifically. Not the body, not the tail, the head. Why? Because sperm whales possess the most powerful sonar in the animal kingdom. Their heads contain the spermaceti organ, a massive structure that generates clicks capable of stunning prey. A healthy sperm whale could use this biological weapon against attackers. Megalodon eliminated the threat by destroying the weapon itself, breaking the jaw, crushing the skull, removing the sperm whale's primary defense before it could be deployed. This level of tactical awareness extends across prey categories. Baleen whales were immobilized through flipper and tail attacks. Sperm whales were neutralized through head trauma. Smaller cetaceans were simply overwhelmed through superior size and power. The fossil record shows no evidence of failed strategies, no evolutionary dead ends. Every adaptation Megalodon developed appears in the fossil record as successful predation. Bite marks on prey remains, embedded teeth in bone, healed scars on survivors. Megalodon occupied a unique ecological role. It was an apex superpredator, a term reserved for predators that feed on other apex predators. Modern orcas occupy a similar niche, but orcas hunt in pods, using coordinated tactics and social intelligence. Megalodon hunted alone, a solitary predator capable of killing the largest animals in the ocean, capable of adapting its strategy to match the prey, capable of maintaining this dominance for over 15 million years across changing climates and evolving ecosystems. The fossil evidence reveals the cost of this dominance. Megalodon couldn't afford specialization. The moment it committed to a single prey type, it became vulnerable to that prey's decline. So it remained adaptable, generalist when necessary, specialist when possible. This wasn't opportunistic feeding, this was calculated versatility, and it worked until the ecosystem itself collapsed. The timeline matters more than most realize. Most estimates place Megalodon's extinction at 2.6 million years ago, coinciding with the Pliocene-Pleistocene boundary. This date emerged from statistical modeling, the optimal linear estimation model, which analyzes fossil distribution patterns to infer when a species vanished. But refined analysis tells a different story. A 2019 study pushed the extinction back to 3.6 million years ago, more than a million years earlier. The revision came from extensive adjustments to the worldwide fossil sample and statistical reanalysis of the data. The extinction window now ranges from 4.1 to 3.2 million years ago. Why does this matter? Because the earlier date coincides with the rise of great white sharks as apex predators. The climate theory, the popular explanation that cooling oceans killed Megalodon, has been debunked. Analysis of Megalodon's global distribution reveals the species inhabited colder latitudes successfully. Its range didn't correlate with warming or cooling trends during the Miocene and Pliocene. Evidence suggests Megalodon was a mesotherm, capable of regulating body temperature enough to occupy diverse temperature niches. Temperature wasn't the killer, competition was. As great white sharks emerged, they competed for the same ecological niche, smaller, more efficient, capable of exploiting prey. Megalodon ignored. The fossil record shows no confirmed Megalodon remains beyond the Pliocene-Pleistocene boundary. The disappearance was total. Geographic changes accelerated the collapse. The closing of seaways between continents, particularly the emergence of the Isthmus of Panama, fragmented populations of both predators and prey. Ocean currents deflected from their usual paths. Migration patterns disrupted. Megalodon's prey base restructured. Large baleen whales altered their distribution after Megalodon's extinction. This suggests Megalodon's presence shaped whale behavior for millions of years, removed the predator, and the prey reorganizes. The cascading effect reshaped ocean biodiversity. Large predatory whales and smaller sharks filled the void. The ecosystem fundamentally transformed. What had been structured around Megalodon's dominance became something entirely different. Even the most powerful predator can be erased by ecological disruption. We now know how Megalodon hunted. The fossil evidence is undeniable. 40,000 pounds per square inch of bite force, immobilization tactics, adaptive strategies across prey species, calculated brutality refined over 15 million years. But the real question is what the oceans lost. Modern whale populations exist in their current form because Megalodon is gone. No living predator combines the power, strategy, and adaptability Megalodon possessed. We've analysed the fossils, we've reconstructed the attacks, but we've never seen Megalodon hunt, only the aftermath. What other apex predators vanish without leaving a trace? If Megalodon, the most powerful predator ever recorded, could be erased, what does that mean for the predators we have left?